Zeros of polynomials. So what we need to know now is how to find the zeros. In the section before, we were given one zero, and then we used synthetic division to try to get our polynomial down to a quadratic equation, and we could find the other zeros. But if we're not given any zeros, we need an approach. So the first thing we have is called the rational zero theorem, and it says put your polynomial in the descending order, and then our possible rational zeros, it doesn't mean they will be, but they're possible, will be plus or minus factors of the constant term, so here, over factors of the leading coefficient, which would be here. So if we write the possible rational zeros for this problem, we have plus and minus, right? Factors of the constant term. Factors of the constant term are 1 and 5 over factors of the leading coefficient. So we have 1, 2 goes in there, 3 doesn't go in there, but 4 goes in there. So we have 1 over everything. So 1 over 1 is 1. 1 over 2 will be a half. 1 over 4 will be 5/4. Then we have 5 over 1 will be 5. 5 over 2. And 5 over 4. And I had an error back here. This should have been 1 over 4. It was 1 over everything. So let's see if I can fix that. Right. So this is our possible rational zeros for this function. Now let's find the possible rational zeros of the other function. So it's going to be plus or minus factors of the constant term, so factors of 8. 1, 2, 3 doesn't go, 4, and 8 over factors of the leading coefficient. So for 9, it will be 1, 3, and 9. So we have 1 over everything, so 1 over 1 is 1. 1 over 3, 1 over 9, and then we have 2 over everything. So 2 over 1 is 2, 2/3, 2/9, and then we have 4 over everything. So we have 4, right, and I'm going to continue down here. So I have 4 over 3. And this is still with plus and minus. And I have 4 over 9. And then I have 8 over everything. So 8 over 1 is 8. 8 over 3. And 8 over 9. So we want to find the zeros of this function. And we're going to start just doing this one by hand. So your first step would be to find the list of possible rational zeros. So it will be plus and minus factors of your constant term, so factors of 63. So 1 goes in there, 2 does not go in there, 3 goes in there, 4 is not going to go, 5 is not going to go, and you can check those by dividing. 6 is not going to go, 7 will go because 7 times 9 is 63. 8 will not go because you have no 2. 9 will go, and 9 times 7, and then 3 times 21, and 63 over factors of 5. So 1 and 5. So we have plus or minus 1 over, or all of these over 1. So we have 1, 3, 7, 9, 21, and 63. Those were all over 1. And then we have all of those over 5. So 1/5, 3/5, 7/5, 9/5, 21/5, and 63/5. Right. Now, if we didn't have a calculator to give us any kind of idea of what to do, we would start just having to guess with synthetic division and pick one, try it, see if it works, and we get a 0 remainder. If it doesn't, then we move on and we try another one. That's kind of ridiculous. And so we will pull up a graphing calculator to find 1 0. That is my suggestion. And so we'll do y equals, we're going to type in the function 5x to the third minus 7x to the second minus 45x plus 63, and we'll tell it graph. All right, and the most we could get would be 3 zeros. Now, we want to check these, because that one looks like a fraction. You can't just eyeball it, right? So this looks like a -3. That is a possibility on our list. So let's do second calc value and let x equal negative, and I'm down, let me move this up a little bit. All right, I'm doing the negative sign. And enter. So we hope it gives us 0. It does. So that is one of our zeros. And we did that by the calculator. So -3 is a 0. We will use synthetic division with -3, and we should get 0 for remainder. So we'll set up, pull our coefficients. So we have 5, -7, -45, and 63. Skip a line, bring your 5 down, right, and -3 is a 0. So we multiply. 5 times -3 will be -15. So will give us -22 times -3 will give us positive 66. Minus 45 will give us 21. 21 times -3 will give us -63. And there is the 0 remainder we expected because we saw that it was a root. Now we have a quadratic. So we have 5x squared minus 22x plus 21 equals 0. And a quadratic we can solve. You can use quadratic formula, or you can try to factor. I would probably go straight to quadratic formula. So we'll try that on the next screen. All right, so we're going to use quadratic formula, and we can pick off our A, B, and C. A is 5, B is -22, C is 21, and we'll plug in. So x is equal to negative b, it's already negative, so this will be positive 22, plus or minus square root b squared, so negative 22 squared, minus 4 times a, which is 5, times c, and this is all over 2 times A. Right, and then you're going to clean up under there. Let's see how much I can write. So, the negative 22 squared, and use your calculator for this. This gives us 484 minus, we get 20 times 21 gives 420. This is over 10. And cleaning up under here will give you 64. So we have 22 plus or minus the square root of 64 over 10. And 64 square root is 8. So we have 22 plus 8 over 10, and then 22 minus 8 over 10. Let's see if I can roll the screen a little bit. So we have 22 plus 8 over 10, which will give us 30 over 10, which is 3. And we have 22 minus 8 over 10, which will give us 14 over 10, and we can reduce by 2, and it gives us 7 over 5. So we expected 3 zeros because our degree was 3. So our first one we found was negative 3. And we have 3 and 7/5. So we'll put 7/5 and 3. There's our zeros. Let's pull our calculator back up and have a look at the other zeros. So this one is probably the 3. We could check it with second calc value. So second calc value, and we could put 3, enter, and that one works. For this one, you can try the 7/5, which would work. Another way to find your zeros, just from the calculator, if we do second calc and choose number 2, zeros, you can use your down arrow or you can do 2 on the keyboard. All right, now I'm going to have to move my cursor and then hit enter 3 times. So I want my cursor to get to the left of this 0. All right, it's clearly on the left of that 0. I'm going to click enter on the calculator. That's a left bound. Now I want the cursor to move to the right of that 0. Whoops. Okay, clearly to the right. Click enter, and then click enter one more time when it says guess. And that gives you 1.4, which is a 0, which is the same as 7/5. All right, we have another problem, and we want to find all the zeros, so we're going to start by looking at the possible rational zeros, and this is the way it looks in my math lab. So we want factors of the constant, and remember you want plus and minus. So your factors of your constant are 1, 3, 11, and 33. And this is over factors of the leading coefficient. Nice, at least this time it's a 1. So our choices are going to be plus or minus. All of these over 1 is still the same thing. So plus or minus 1, 3, 11, and 33. On your choices, you're going to have to choose B so that you would have 4 boxes. And this would be your choices without the 1 on the bottom. All right, now we could pick one of those and start trying with synthetic division, or we can pull up our graphing calculator and find one zero that works. So we will go that route. I went ahead and entered those. So now we'll say graph. Right, so it looks like a -1 is a 0. And so let's double check that. So we'll do second calc value. And we're looking at -1. So second calc value -1. Enter. And that works. So that is going to be one of my zeros. And if we looked at the others, this one looks like a 4, but 4 is not a possible rational zero. So we could find it off the calculator by moving to it. So we could do second calc 0, which is number 2, and we want to move around and be on the left of it. Okay, and back down. All right, so I'm on the left of it. I click enter. I want to get to the right of it. Whoops. Click enter. And now you have guess. Click enter one more time. Right. So I am at 4.08. So, and this is a decimal that keeps going. Doesn't repeat, and it doesn't terminate. So that, if you remember back to your definitions, is an irrational number. And so we would end up with a radical on that. So we're going to go ahead and try to find out what that radical is instead of going with this value. And so that's why you would want to go back to the synthetic division, because we'll be able to get that out. And you can try this other one if you want. 1, 2, 3, 4, 5, 6, 7, 8. 8 is not on here as a possible rational zero, and so it's probably going to be another irrational one. So we'll put the calculator away. So now we'll do synthetic division. We found -1 by the calculator, and we will try to get our quadratic equation out of it. So we'll do -1. Our coefficients, we have 1, 5, -29, -33, and this was a 1, sorry. 1 times -1 is -1. This gives us 4. 4 times -1 is -4. This gives us a -33 times a -1 gives us positive 33. And 0 for a remainder, which is what we expected. So now we would drop 1 degree lower. We have x squared plus 4x minus 33, and that is the quadratic that we want to solve. It is not going to factor, so again we'll go to the quadratic formula. So we'll go ahead and plug into the quadratic formula. And I wrote our A, B, and C on the side. So we're going to do -b plus or minus square root of 4 squared minus 4 times A times C all over 2 times A. So we have -4 plus or minus 4 squared gives us 16. 2 negatives in there will be plus, and that gives us 148. All this is over 2. Put this together. I'm sorry, we're going to backtrack here. I was ahead of myself, and I'm not going to redo this clip. So this was actually not 148 yet. It was 132. And this gives us -4 plus or minus square root of 148 over 2. Let me scroll a little bit. All right, and then we can simplify this radical a little bit. You can do it on the side. So 148, it has a 4 in it. And so just divide 4 goes 37 times. 37 is a prime. So for your 4, take your square root, which will be a 2. So that will go outside. So 2 times the square root of 37 is what this radical simplifies to. So we have -4 plus or minus 2 times your square root of 37. This is over 2. Now, you have to be careful and simplify this. In your triangle here, you have a common factor of 2. So you're going to divide it out, and it'll go into 4 2 times. So we're going to have -2 plus or minus the square root of 37. And if you test that on your calculator, you can see it's those values we came up with. So we'll just clear. So if we do, so I'm entering -2 plus square root of 37. So second square root of 37, close your parentheses. And see, there's that 4.08 number. And if you do -2 minus the square root of 37, let's just go ahead and do it. It's the 8 point something. So -2 minus second square root 37. Enter. So it's your -8.0. So these two are irrational zeros. They weren't in our rational list. That's why it helps to make your rational list. And so to give the zeros, we want these two plus the one that we found, which was -1 when we're entering our zeros. So for our zeros, we have -1 and we have -2. I'm just going to leave the plus or minus square root of 37. You can figure out what MyMathLab makes you do.